Fixed cost. Fixed costs are costs that are fixed, right? Right, so it's true that fixed costs are costs that are fixed, but importantly, fixed costs are costs that don't vary with the production volume. So whether we produce 1 unit or 1 million units, the fixed cost is still the same. That's why it's so important to establish what your fixed costs are, how much your fixed costs are. Because think about it. Think about what I just said. Your fixed costs are the same whether you produce 1 unit or 1 million units. So if you only produce 1 unit and your fixed costs are $1 billion, is anybody worried?
Yes.
You have fixed costs of $1 billion and you only sold 1 unit, or maybe you didn't make any units. So we have to pay attention to our fixed costs, because ultimately what we want to do is to be able to spread those fixed costs across as many units as possible. That's known as fixed cost absorption. So each unit that we produce is going to absorb a percentage, an amount of the fixed cost.
I'm just thinking, I think the idea is that over time your fixed costs should go down as production, use of production. So therefore, would that be part of variable cost?
Well, are you talking about your total fixed cost or your unit fixed cost? So we have, our total fixed costs are going to stay the same. But what I'm suggesting is with fixed cost absorption is that the more units that you produce, each unit is going to absorb a smaller amount.
So over time, then it's the unit cost that...
Well, we don't know. I mean, we could make that assumption.
No, I'm just saying like, so based on this assumption that over time, the input should be lowered, I don't know, would that be...
But in some industries that could be true, and in some industries that's not the case. But I know what you're saying, that ideally we would have some economies of scale. Yeah, that so over time, that when we produce...
The same.
When we produce a large number of units, that our total fixed costs would go down. We would hope that's the case. It's not always the case in every industry. And variable costs? Variable costs vary with the production quantity. So the more units that we produce, the greater our total variable cost. Now, our unit variable cost should stay the same. Unless, for example, we were able to negotiate with a supplier of materials and we're actually paying less, let's say, per ounce of plastic. So, if we think about our product costs, also sometimes referred to as our manufacturing cost, that includes direct materials, direct labor, and manufacturing overhead. Now, our direct materials, let's say, for the product that we're producing, which is made of plastic, let's say that we're paying for 1 ounce of plastic 57 cents. And we're purchasing 10,000 pounds. But now, when we increase our production volume from 10,000 pounds, we now need 100,000 pounds. So, of course, our variable costs, our total variable costs are going to increase. Let's say we use 1 ounce. Let's say to make our product we use 1 ounce of plastic. That means our variable cost, if that's our only variable cost, is 57 cents. If we make 2 products, we use 2 ounces, that's $1.14. If we make 10 products, then that's what? $5.70. Right? If we make 100 products, then that's what? $57. for plastic to make 100 products, we're using 1 ounce per product. And we said that the plastic costs us 57 cents. Now, the unit variable cost is still 57 cents. But what I was suggesting is that maybe when we produce 100,000, when we produce enough products that we need 100,000 pounds of plastic, so 100,000 units, well, more than 100,000 units, probably like 1.6 million units, that the supplier would give us a discount. Then our unit variable cost might decrease. So in other words, instead of paying 57 cents per ounce of plastic, maybe we're getting it for 53 cents per ounce. But we have to make a distinction. There is when we talk about variable cost, we have a unit variable cost, that's how much our variable costs are per unit, and our total variable cost. So when we say that our variable costs increase with the production volume, what we're talking about is our total variable cost. So if our variable cost was $1 and we made 10 units, then our variable cost would be $10, our total variable cost. If we made 100 units, then it would be, our total variable cost would be $100. If we made 100,000 units and our variable cost was $1, then that would be our total variable cost would be $100,000. So you see why I say that variable costs increase with the production volume? Why they vary. It increases with the production volume. So whether you make 1 unit, or 10 units, or 100 units, or 100,000 units, you see we went from $1 to $10 to $100 to $100,000 in total variable costs. Our fixed costs haven't changed. It's still $1 billion. Our total fixed costs have not changed. It's still $1 billion. But our variable cost, the more units that we produce, that continues to increase. The total variable cost continues to increase. If we don't make any product, then our variable cost, our direct materials, our direct labor, is going to be 0. If we don't make any products, our direct materials and our direct labor is going to be 0. But we said variable costs vary, right? Variable costs vary with the production volume. So the more units that we make, the greater our total variable cost. Questions about that? Does that make sense?
So when you're talking about the programming course, like under variant course, we're talking about the total variant course.
Right. So there's a number of ways that we could classify costs. We could look at manufacturing costs, which are known also as product costs, non-manufacturing costs, which are known as period costs. So for example, the product cost would be, a good example would be cost of goods sold. So the product costs are the costs associated with making and acquiring a product. What would some of those costs be? The cost of goods sold. Which we know that at the time that we receive those raw materials, they're what are called inventoriable costs. But once that inventory, like the plastic, becomes a part of the product, then it's designated as cost of goods sold. But non-manufacturing costs would be period costs, expenses that are not directly associated with the manufacturing of the product. Like what? Sales commission, for example, selling general and administrative. Those would be example of period costs. Sales commission, advertising. So we could classify costs in different ways: fixed costs, variable costs, product costs, period costs, and Shanae was telling him about program costs and committed costs, and Jimmy is going to tell us. Yes?
I just want to ask a question. Are taxes considered like variable costs?
Taxes. Are taxes considered to be variable costs?
If you earn more income, then you pay more taxes, right?
I wouldn't consider that to be, but what type of cost would that be? It's not directly related to manufacturing.
but it's like indirectly.
So I would say that that's an example of a period cost.
So when you're talking about the fixed cost absorption, you mean like, that's when you're talking about the unit per cost is going down as the...
Yep, absolutely. So the unit fixed cost is going to go down. The total fixed cost is going to be $1 billion, but the way that we're going to be able to make money is that we're going to spread that $1 billion over, instead of 10,000 units, 10 million units. Now we have a chance at being profitable. See, that's the thing that put the stranglehold on US auto manufacturers, is in the 70s, they had built this huge infrastructure to produce millions and millions of cars. They were the market share leader. We talk about market share, right? They were the market share leader. So they had fixed costs in the billions, many billions of dollars tied up in manufacturing facilities and equipment. Then their market share declined. Toyota started selling, for example, cars in the United States. And their plan was to penetrate every segment of the automotive industry. And what happened was, as their sales declined, the unit fixed cost continued to increase. So that means that each car they produced had to absorb a significantly greater amount. So each car had to absorb a significantly greater amount of the fixed cost. That means you're becoming less profitable. Now we need to talk about sunk costs and relevant costs. Sunk costs are costs that we've already paid. Sunk costs, it's a cost that we've already experienced. It's an expenditure that's already occurred. And importantly, that expenditure should not have a bearing on any future decision. We've already paid that money. It shouldn't have any impact on whether we go forward with our particular product or not. So that go, no-go decision, if it's a sunk cost, it shouldn't have any bearing on whether or not we go forward with the new product or we don't. Because we've paid that money already, and it shouldn't have any impact. So of course, we've already spent $500,000 in research. We spent $500,000 doing research. We shouldn't be sitting there telling ourselves, well, if we don't go forward with developing this new product, we lost $500,000. Of course, that money is spent. But better to have spent that $500,000 and find out that there's not a market for our product, that the purchase intent is low for the product that we're offering, that we were intending to offer, than to go forward and now spend $3 billion in manufacturing. $3 billion in manufacturing equipment and tooling. So we would argue those costs are sunk. We spend $500,000 on research. That shouldn't have any bearing. The opposite of a sunk cost is what's known as a relevant cost. So a relevant cost is a cost that we haven't paid yet. We haven't expended the money. Remember we said a sunk cost is an expenditure that has already occurred. We already spent the money. A relevant cost is one where the expenditure hasn't occurred. And it does have a bearing on our decision. So basically, isn't that the opposite of a sunk cost? So the relevant cost is one cost that we haven't paid yet. We didn't experience that expenditure yet, and it does have a bearing on future decisions. So if we're thinking about whether or not we're going to go forward, if the next decision point means, well, whether or not we spend $1 billion, because the $500,000 is gone, that $500,000 is gone. We said we're not going to consider that. That's a sunk cost. But what about future expenditures? If the next decision point is, do we spend $1 billion or not, and we haven't, and we're considering that as part of this process, then that's considered to be a relevant cost. Questions? So we talked about fixed cost, total fixed cost, and unit fixed cost, total variable cost, and unit variable cost. So as a clarification, we said variable costs, they vary with the production volume. But when we say variable costs, we're talking about the total variable cost. The unit variable cost should stay the same. Unless, like I said, there was a unique situation where we were able to negotiate a lower price for the raw materials per unit. All right. Break-even volume. What is the break-even volume? How do we compute that? We take the total fixed cost and we divide that by the unit selling price after we subtracted the unit variable cost. So let's take an example. Let's say that the total fixed cost is $30,000. If our selling price is $5, and our unit variable cost is $2, so what we're going to do is we're going to calculate the break-even volume. This is the formula. We take the total fixed cost and we divide that by the unit selling price. How much do we sell it for per unit? And we subtract the unit variable cost. See, we're talking about the unit variable cost. The total variable cost could be $2 million. If the total variable cost is $2 million, what does that tell us about how many units? What's the total number of units then? How much? How many? I think somebody said it. Well, if our total variable cost is $2 million and our unit variable cost is $2, then it's $1 million. So our break-even volume here is what? 30,000 divided by 3, right? So what is that? 10,000. Best business students ever. Right, Caroline?
Yeah.
Yes. Best business students ever. So 10,000 units. What that tells us is that in order for us to break even, not make money, just to break even, we'd have to sell 10,000 units. This is extremely important because this is going to give us a sense. So when we're doing an analysis of an opportunity, this is going to give us a sense as to whether or not we should pursue this opportunity, whether or not it's feasible. So if I told you that the size of the market was 5,000 units per year in the United States, what do you think about the feasibility of our initiative based on this break-even volume? What do you think? Is it something that we should pursue? Should we pursue this project or no? How many say don't pursue? Raise your hand. 2 people. How many say pursue? 2 people. See, it was the same 2 people. All right, so this is what Coach thinks. If we've computed the break-even volume to be 10,000 units, and the size of the market is 5,000 units, that means that it's not something that's feasible for us because we'd have to sell twice the number of units as the total market just to be profitable. What would be our payback period? How many years would it take us to break even?
Well, I would just like to name an exception because Apple is still planning to sell a lot of watches, right? And the market for watches is really, really small compared to the amount they're producing. So it's just an exception.
So right now, so what Jimmy is saying is in the introduction stage of the market. We're going to talk about the new product life cycle. So at the introduction stage, it might be more challenging for us to actually even compute the break-even volume. Right? Jimmy, what would you think would be the break-even volume? And who are our competitors? When we say the market, is it all watches?
Well, the point I was trying to convey was because you're saying, because the break-even volume over here is 10,000 units, and the total market shares currently is 5,000 units. We were saying it's unfeasible, and I'm just naming an exception because currently I think last quarter there were like 600,000 digital watches that were sold, and Apple's planning on selling millions of these watches for 2015. So I was just naming an exception.
So Jimmy is saying basically that what I'm assuming in my scenario is that it's a mature market. So I'm assuming that it's a mature market and the size of the category is 5,000 units per year. And that's not going to grow significantly in the near future. It's not going to grow exponentially. It's not going to grow geometrically. So if I told you that the size of the market was 100,000 units in our mature category, then 10,000 units, they might seem feasible. So we would have to sell 10,000 units. We'd have to basically get a 10% share, which could be very challenging in a highly concentrated market, certainly. And a mature market where the size of the market is stable, which is a good thing, so it could be large, but it's not growing, or it might be growing only 1 or 2% per year. So this is important in terms of assessing the feasibility of initiative, determining the break-even volume. The size of the market is significant. We need to know what is the size of the market, and then compare that to what we computed to be the break-even volume. All right, let's take an example regarding trade margin. Let's say, for example, we sell a product for $20. We sell the product as a retailer, we sell the product for $20, we buy it for $10. So as a percentage, our margin as a percentage of the price is 50%. So basically that's just 10. This is our margin. $10 is our margin. So I told you that it's a product that we sell for $20. If we sell it for $20 and we buy it for $10, that means that our margin is $10. If I told you that we sell it for $20 and we buy it for $15, then our margin would be what? $5. So $20 is what we sell it for. If we buy it for $15, we'd have to subtract the $15, what we bought it for from the price, right? Yeah. That leaves us with $5 of margin. What about if we sell it for $20 and we buy it for $5? Then how much is our margin? How much?
Don't do it.
$15. Why? We sell it for $20, we buy it for $5. That means our margin per unit is $15. So what I suggested was we buy it for $10 and we sell it for $20. So how do we calculate our trade margin? Well, if we buy it, to go back, right? If we buy it for $20, if we sell it for $20 and we bought it for $10, that means our margin per unit is $10. So as a percentage of the price, our margin as a percentage of price is 50%. That's very common in retail, to compute the margin as a percentage of the price. So we're selling the product for $20. What is our trade margin? 50%. 50% of the price is what we're selling, is what our margin is. So our margin as a percentage of the price. Our margin is $10. The price is $20. So that means that our margin as a percentage of price is 50%. But we can compute our margin as a percentage of cost. Margin as a percentage of cost would be $10 over $10, right? So our margin over our cost is $10. That means our margin as a percentage of cost is 100%. But very often, in retail, we look at margin as a percentage of price. So you see the difference? The margin is a percentage of price, we said was 50%. Our margin as a percentage of cost, in this example, is 100%. So it matters. So when you talk to retailers, you need to make sure, when you're talking to the buyers and retailers, you need to make sure that you're both on the same page, whether or not when you say 50 points or 100 points, that they know that you're talking about 50 points as a percentage of price. Because you see the difference in terms of a percentage of cost, that would be 100%. Best students ever, ever.